Now we're recording. See it's moving. See it's going up and down the green that's recording your voice. Okay?
No, but you don't record it, it still goes up and down just because of your voice.
Yeah, but it's green when it's recording.
Anyway,
It's always green.
25 seconds wait.
25.
Okay, so just to recap then, we're doing probability. We talked about mutually exclusive events. Mutually exclusive events are important because you have to take those into consideration when you are calculating a probability. So, two events are mutually exclusive when they cannot occur at the same time. And that's when I do one thing. Right, so that's important to explain. So, for instance, if I take a card out of a pack of cards, tell me two things that cannot both occur on one card.
You
You
can't
can't get two different, like you can't get, for example, the Queen of Hearts and the King of Spades
No.
at the same time.
Exactly. I cannot get the Queen of Hearts and the King of Spades at the same time with one card. So those two events are not mutually exclusive. The two events that, no, sorry, they are mutually exclusive because they cannot happen. Two events that are not mutually exclusive could both happen at the same time on one card. Can anyone give me two things that could happen with one card? Two different things. Ollie, this time.
When you get an 8 of Hearts and you get a heart, I don't know.
Well, you could say I could get an 8 and a
Even number.
hearts, right?
Even number of hearts.
Well, no, what you said was fine. I can get an 8 and a hearts. They are not mutually exclusive because I can have the 8 of hearts. So they're not mutually exclusive. Anything else? I could have an 8 and
Diamond.
even number. I could have an 8 and a diamond. I could have an 8 and a number that is greater than 7. I could have a king and a
Spades.
spade. All these things could both happen. But yeah, so they are not mutually exclusive. Mutually exclusive, I can't have a king and a queen. I can't have an 8 and a 7. Okay? And things like that. So that was explaining mutually exclusive to you. What was important about mutually exclusive? Well, if we consider probability of rolling a dice, what is the probability of getting a 6 or a 4? Well, we said with this fancy notation that you now are perfectly happy with, you add the probabilities together. So the probability of getting a 6 or a 4 is 2 out of 6 because you add those. The probability of getting a 3 or an even, well, probability of a 3 was 1 out of 6. The probability of even was 3 out of 6. Add them together, 4 out of 6. So there are the numbers. When we don't have mutually exclusive, for instance 4 or even, you can't just add them together because 1/6 for 4, 3/6 for even makes 4/6, but that's incorrect. I think Hannah, you told me why it was incorrect, because 4 is even. So I can't add them together, because actually how many numbers are 4 or even? Well, 2, 4 and 6, so that makes only 3 numbers. So it should be 3 out of 6, just because 4 and even are, and therefore 4 and getting an even number are not mutually exclusive, so we have to take that into consideration. Okay? Right. Today's objective then, using our knowledge about mutually exclusive, okay? So a long objective. But I want you to be able to calculate a probability of combined events using two-way tables and then tree diagrams as well. So you don't use both to solve the same problem, you don't need to, but sometimes a two-way table is fine, sometimes you have to use a tree diagram, and you'll decide which one for which.
Is a tree diagram the thing where you put the number and you get the factors, and then you get the factors?
Well,
of
that's
the
a different
factors?
form of a tree. You're talking prime factor decomposition, where you use the tree. Similar idea with lines, but it's for a different purpose, but used in a different way. So you are going to, obviously, part of this will be to know what a two-way table is, okay, and also what a tree diagram is. So we obviously need to do that. What they are, how to use them to find the probability. Alright, so let's start with a problem where you would need to use a two-way table. Okay. So, what we have to consider in this sense is now, it's not one thing happening, so it's not one card being picked. We're now doing more than one thing. Okay. So what we're going to go for is this situation. 2 dice are rolled. Okay? 2 dice are rolled. Right? And I've got the question, what is the probability of getting, right, a total more than, what should we go for? 8. So what is the probability of getting a total more than 8? What do you reckon?
Wait, no, does that really have to, like, so for example, like 5 and 3 is 8, 4 and 4 is 8.
Exactly.
Does
Yeah.
that mean we have to work out how many numbers you can add together to make 8, and then that's...
Yeah, so we have to figure out how many ways of making 8. So total means add. So what do you reckon, Igor?
1 out of 3.
1 out of 3. You reckon? Why would you say 1 out of 3?
Because the maximum total you could get is 12, and so 4 is 1 out of 3, and this 8, so it's 2 out of 3, and the probability of getting more than 8 is 1 out of 3.
It's quite a simplistic way of looking at it. We'll see. We'll see what comes up. What's important with probability? I've told you. What's probably the most important thing when you start your probability?
You know how many of the dice there are.
I thought you were going to say the right thing then. Not how many dice. We've got how many dice? 2. What is actually the most important thing? Lauren?
the total is always 1.
Yeah, that's one thing. Actually, that is probably the most important thing. The probability is always at 1. But when we're trying to work out the probability, what is the most important thing?
Number of numbers.
The number of,
The amount of numbers.
not numbers, but possible
Outcomes.
outcomes. We have to know what the total number of outcomes can be, right? So in this case, what we have to look at is how many possible answers are there. If we're looking at a total more than 8, we need to know how many possible totals are there. And what would you say? What do you think the total possible number of outcomes could be? Because this is where people normally go wrong.
Is it 12?
Why did you say 12?
Because the highest number on the dice is 6, and there's 2 dice.
Okay, so you think because 6 add 6 is 12, there are 12 possible outcomes, yeah? Well, what about, can you get 1?
Yeah.
Isn't it 1 out of 1?
No, you can't get one.
Can't get 1,
Oh.
because it's got to be,
Yeah.
the lowest score
There's
is
no
1
10.
add 1,
There's
is
no
2. So the lowest score is 2. Can you get 3?
Yes.
Yeah, 1 add 2. Can you get 4?
Yes.
Yeah.
Obviously, 5, 6, 7. So you would tell me that the total possible outcomes are
11.
11, okay. And the probability of getting more than 8 would therefore be
3.
9, 10, 11, 12.
Oh, 3.
So 4 out of the possible.
But you
11?
said that there were 11.
Yeah, then
But
said
you
there
come
was
to 12.
So it is 3,
No.
not 4.
No, because the totals. How many possible totals are there? 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12.
Yeah.
There are 11 possible totals. How many more than 8? 4. 9, 10, 11, 12. 4.
Why don't you go to 11 though? Why don't you go to 12?
The totals that are more than 8.
But you just said since we can't get 1,
You
it's
can get
11.
to 12, but you can't get to 1. So there is 12 numbers, but there's only 11 outcomes. Because you can do 6 and 6 is 12, but you can't do 1 and 1 is 1.
So the
It's up to
possible, right, we've got to be careful here because I'm leading you down the wrong direction for a reason. But when we talk how many possible outcomes are there, people normally say, well, 1 add 1 makes 2, that's the lowest. 6 add 6 makes 12, that's the highest. And I can get anything in between, yeah? So we would say I can get a 2, a 3, a 4, a 5, a 6, 7, 8, 9, 10, 11 and 12. That would make the total number of outcomes 11, yeah?
Mm-hmm.
Mhm.
Yeah? What would you say?
But, oh wait, no, so, 11.
Okay, and how many of those are more than 8? 1,
4.
2. So, quite a lot of people would say the probability of getting a total more than 8 is 4 out of 11. However, that's wrong. Anyone know why it's wrong?
Is it because you don't look at what the outcomes are? You look at the numbers on a dice because yeah, the combination. So like 5 and 3 or 4 and 4 or whatever.
Okay. You're getting somewhere. What we do need to consider combinations. So how many different combinations are there?
That's what you have to work out.
Okay.
'Cause
Isn't it
and so it's not what
No, it's not infinite.
no because
Not when
you
we've got
have
6
like
numbers.
you have 5 and 3. And
So what you're
4
saying,
and 4, 6
actually,
and 2,
how many ways are there of getting 12?
2.
Oh, 2.
One.
2.
One. No,
One.
there's one.
Why?
6 and
six
6
Oh,
makes
yeah.
12.
Ah!
But there's like 5 and
How many
3,
ways
4
are
and
there
4.
of making 11?
2.
2.
On the first one, 6 and
How
5.
many
And
went?
the other one, 5 and 6.
Okay. So actually, there's 1 12, but there are 2 11s. How many ways of making 10?
5, 5. But,
1.
5,
but
5.
you can
4,
also use
6,
6, 4 and stuff like
and
that.
so 3.
So it's not
Right.
just 1.
Oh,
Exactly.
Or
So
11 and not
here's the
12.
problem.
Because 1, 2, 3. that
Here's
way.
the problem. There are more than 11 outcomes because there is only 1 12, that's fine. There is only 1 2, that's fine. But how many ways are there of making 7, for instance? We can't write 1 7, there's lots of 7s, there is more chance of rolling a total of 7 than there is of rolling a 2, yeah? So we can't say, remember we had this problem you have to take into consideration. If I said to you, pick a number and I'm going to roll 2 dice and you get the score, if you're right, you win a dragon or whatever, which number would you pick out of there to choose to have the total? Would you pick 2?
No.
No, because it's really hard to come up. Would you pick 12? No. Which number would you pick?
7.
7. Okay, maybe. So we need to think about that. Yes, Sam.
Is it 7 is the meeting point because 7 is you can find 7 6 ways and then you can find 6 5 ways but you can also find 8 5 ways. So 12 and 2 you can find once, 11 and 3 you can find twice, and then it goes
Okay.
up to 7's the meeting point.
So we've got, she's a genius, we've got to consider that there are more ways of making certain them. Now, we need a better way of actually recording all these,
Put it in the
right?
table.
And we're going to have a two-way table. And the two-way table is where you have 2 things and we have the 2 dice. The 2 dice are numbered 1, 2, 3, 4, 5, 6, and the second dice 1, 2, 3, 4, 5, and 6. Now,
Like
I've
6?
written it like that. Okay, and I'm going to write it as a table. And this tells me automatically how many different outcomes there are. How many possible outcomes are there? Now,
Mr. Potts, why did you write 6?
because I've got a dice with numbers
Ah.
1 to 6 on. So this could be dice number 1, and this can be dice number 2. So how many possible outcomes are there? Actually, well, I get a 1 and a 1, a 1 and a 2, a 1 and a 3, a 1 and a 4, a 1 and a 5, a 1 and a 6.
36.
So there are actually 36 possible outcomes. Okay? 36 possible outcomes. So that 11 that we tried was obviously way off.
So we have to write out of 36.
So it's going to be out of 36.
Oh. So the maximum amount that you can get on one dice times the other dice. So like if there was 3 dice, it'd be 6 to the power of 3.
72.
Smart.
And if there were 4 dice, 6 to the
Smart.
power of 3.
Yeah, smart. Okay. So with 2 dice, we've got a two-way table. How many of the options have a total more than 8? Well, actually, that's all I really need to work out then. So 6 and 6 makes
36.
12.
Ah!
Then we've got the 11. This is what Hannah was saying. There's 1, 12. There's 2 11s. There are 3 10s. There are 4 9s. There will be 5 8s and 7. But we're not interested in anything that's 8 or lower. We only want to know the probability of more than 8. Okay, on the dice. So how many ways are there of getting more than 8?
10.
Wait,
10.
but there's no possible way to get 1, so it would be
10, 11, 36.
That would be
Yeah, that's not a 1 though, it's a 2.
1 and 1.
5
Oh,
over
I did.
8.
But I'm not really interested in the rest. I only want to know the ones that I want to know. Okay?
And if it's less than 10, it will go the other way.
If it's less than 10, oh, sorry, less than 8,
Yeah, less than.
then it will be what? Actually, you should be able to do that quite quickly.
Oh, yeah.
So the
6.
probability of should we say 8 or less?
Oh!
What must these two add up to?
21.
1. So if we know that this one's 10 out of 36, 8 or less will be
26.
26 out of 36. Because it will be 1 minus 10 out of 36. Okay?
What about 8?
But what was
So-
important, now remember I've said 8 or less, because that's the opposite of more than 8. If I said just less than 8, it would have been different.
Yeah.
That wouldn't have included the 8s.
Mhm.
So that's a two-way table, and we can use it to find this most important number, what it's out of. Because you can see that if we didn't do that, we thought 4 out of 11, which was just completely wrong. Go on, what was your question, Hannah?
Why did you do 1 minus 10 over 36?
To find 8 or less. Because probability of more than 8 and the probability of 8 or less are two what we called what last lesson, for those of you that got that far. Those two events
Executive.
are,
Mutually.
they are
Exhaustive.
mutually exclusive and exhaustive. Okay, those two events are exhaustive because there is nothing else. You are either more than 8 or you're 8 or less. You can't have anything else. If I said more than 8 and less than 8, would that be exhaustive?
But that's,
No,
but that
because
can't
8
be
itself is left out.
Exactly. If I said more than 8 and less than 8, that's not exhaustive because 8 still has to be considered. Okay? But because I said, I almost did it wrong here, look. I almost put just less than 8, but I changed it to 8 or less. So that one and that one are exhaustive. Okay? Therefore, both of them have to add up to 1. So I have to do the 1 minus. Okay. Any questions on that? The two-way table is quite useful now. So if I said to you now, you've got the same two-way table. What is the probability of rolling the dice and getting a total, okay, getting a total that is a prime number? What is the probability of getting a total
On two
prime
dice.
number?
On 2 dice.
Well, I've rolled 2 dice.
Miss
I'm
Paul.
going to pause and then I'm going to come back to you in a minute. Okay, and we're back in the room. Right. So, you'll notice that I have magically filled in that. If you're watching the video, it will look like magic. I've filled in, so we've got all the outcomes written now. So we now want to know the total that is a prime number. So,
15.
the total number is still
15.
36.
15.
So what we do
25.
is we go through the grid and we have to mark out how many prime numbers there are. So 2 is a prime number, 3 is a prime number, 5 is a prime number, 7 is a prime number, 9 is not a prime number, although people tend to write 9 as a prime number for some reason.
Because they think it's all odd numbers.
Yeah, they think the odd numbers. 11
How many?
No, because
is a prime number.
I think it's 15.
So we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So the probability of getting a prime number is 15 out of 36.
이거 얘기 объясню.
It's 5 out of 12.
I swear I lose.
If you
I yelled 15. No one listened.
It can be stated as 3 out of 12.
5 out of 12.
5 out of 12, sorry, yeah.
No, 3
5 out of 12 is fine, but that doesn't make 15 out of 36 wrong. Because in probability, you don't have to simplify.
What? But if you got all the prime numbers, it's 2, 3, 5, 7, 11.
Yeah.
And you put them in a two-way table. I got 25.
That's our table for the 2 dice, yeah?
Yeah.
How many ways are there of getting a prime number?
I said that first and then I changed it. 'Cause
I think what you were writing the prime numbers on the dice.
Yeah.
Well, that's not. The dice are the dice. Okay, I've got a question for you. I don't think we're going to get as far as the tree diagrams today. We're going to do another 2-way table. I'm going to get you to write your own. Please stop talking over me. It's all recorded. I have evidence. Right? I'm going to ask you to solve your own problem now. Create your own 2-way table. So, basically, you need to remember, you need to know this number here. The possible outcomes. That number, right, it was all important. Possible outcomes. If you don't know that, you're not going anywhere and you're doing it quite fast. Okay, so, different question. Okay? There is a classroom. In the room, there are 12 girls and 7 boys. Okay? Right. If I select 2 people, okay, what is the probability of selecting a boy and a girl? Okay, so basically your classroom with you in it, 12 girls, 7 boys. Okay, there's 19 of us in the room. You tell it's 19 because Alex is sat there on her own little table on her own at front at the moment. We're going to move around the room so that someone else sits on their own. Okay. I'm going to go out the room and I'm going to sort of come in and point. My arm will reach out and grab one of you by the scruff of the neck and pull you out the room, and then I'm going to do it again without looking. I'm not actually going to do it.
But you know our places.
Right? No, you can mix around, so it's random.
Okay.
So I don't know. I will just reach in and I'm going to grab 2 people, one at a time.
Are you actually
Right?
Oh my gosh.
How does my arm reach to Irfan's table?
You could walk in.
I'm not going to. Imagine I missed a stretch. I just grab 2 people. Or I'm blindfolded and I do it. I definitely don't want to do that. Okay?
Okay.
What would be the probability that I select a boy and a girl? Like, I have not 2 boys, not 2 girls, I have a boy and a girl. You need to work out the probability that I have a boy and a girl. Okay?
Вообще 19.
Okay, so, careful what you say again.
Yeah.
So, you're obviously struggling a bit more with this one, yeah?
Yes.
Does the 2-way table fit?
No.
No.
You don't need it.
No, you can't use it. You can't.
I
plus.
didn't
Yeah,
use it at all.
but
I
you
just
said
rolled
three
12 out of 29.
Oh,
Okay.
yeah.
Shush you.
So,
But you said we weren't going to do
22.
tree diagrams.
right,
when you
well,
started.
the thing is, you can use, right? It is almost time, you're right.
Wait, did you just record the whole thing in the shower?
No.
No.
Okay.
Now, yes. No. So you can do yourself a 2-way table. Okay? Person 1, person 2. You work it, what do you need to work? You need to work out the combinations. Right? But there is a problem when you do something like this, and that problem is,
You can't add a boy and a girl together.
Good job.
well, I didn't say you had to, I just
No,
said
but-
I have to take 2 people. The problem with this situation, which we have to consider next time, is the fact that when Ollie, having a chat away, that one is recorded now. When I take someone, I don't put them back in the room. And that leads
Oh.
us to a whole new situation. that
Oh,
we're talking
Jesus.
about.
Because
Right.
to be
We'll
continued.
talk about it.